Hello and welcome to video 3.3, which is proving lines parallel. So the first thing we need to do is go through some more theorems that go along with this section. The converse of the corresponding angles theorem. Converse, remember, basically means opposite. So if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. And if you remember from the section before, corresponding angles theorem said if two lines are parallel, then the corresponding angles would be congruent, so it's like the opposite of what this said. Theorem 3.5, converse of the alternate interior angles theorem. Again, it's the opposite of that other theorem. If two lines in a transversal form alternate interior angles that are congruent, then two lines are parallel. So now we're not sure if lines are parallel, and we can prove that they are knowing these things. Theorem 3.6, converse of the same side interior angles postulate. If two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. And theorem 3.7, converse of the alternate exterior angles theorem. If two lines in a transversal form alternate exterior angles that are congruent, then the lines are parallel. And so now I'm going to move the screen down and I will show you this example, and I will go through these theorems with you, and we'll just start with the one that you can actually see on the screen right here. Converse of the alternate exterior angles theorem. So if 1 and 7, which are alternate exterior angles, if you can prove that they are congruent, you know that these two lines that the transversal crosses is parallel. The two lines are parallel. The same side interior angles, so 3 and 6, if I can prove that they are 180 degrees, which is supplementary, then I would know, again, that these two lines are parallel. Then you had the alternate interior angles, which would be like 3 and 5. If we can show that those two are congruent, we would know that these two are parallel. And then the other one was the corresponding angles. So if we can prove that 1 and 5 are congruent, we would be also able to prove that K and M are parallel to each other. So the flow proof. A flow proof is a proof, you're still proving, it's a proof, but it's a different way of writing it. You write it with arrows that show the connections between the statements and reason, and then the reasons are written down below the statements. And so we're going to use this example right here. The information that's given is right here. The measure of angle 3 and the measure of angle 6 equals 180. And so we should be able to pair that with a theorem from up above. But it says prove that K is parallel to M. Prove it. Given what they give you through a series of steps, can you prove it? Measure of angle 3 plus measure of angle 6 equals 180. That's what they gave us. So we know that. If you know that, what can you do from there? You can show that 3 and 1 are congruent because they're vertical. So the reason is vertical angles are congruent. So now we prove that 3 and 1 are congruent. So now I can prove that measure of angle 1 is congruent to measure of angle 7. How do I know? Because the alternate exterior angles are congruent. And since we already know that 3 and 6 add up to 180, 6 and 7 have to add up to 180 also. So K is parallel to M. If alternate exterior angles are congruent, then the lines are parallel. That's my reason behind that. So again, just more information of the same thing, but just a different type of proof. So bring that information with you, and we'll continue on with that same type of thinking in our next section. Have a good night.